How do you turn your project requirements into a solid implementation? In this video, we'll build on what we did in the last video, taking our project requirements, breaking it down into tasks, and then using LLMs to implement the calculator using a test-driven approach. So I have a set of requirements here now. Let's break that down into actionable tasks. Okay. Based on the project requirements, could you produce a clear set of steps that we can follow one by one to implement the project requirements? Okay, so basically what I'm doing now is I'm feeding the project requirements into the LLM, and I'm now asking it to break it down into a set of tasks that or steps we can do in order to implement this very, very basic calculator. Okay, and we see it gives us Rust calculator, navigate to the directory. Right. Create the different error types. Yeah, so it got this wrong. We don't want to do it this way. We want to make this test driven. And so the whole idea here is we will define a set of tests, use those tests to make sure that that our implementation is correct. And this is absolutely key for what we're doing here. Make sure that, so we're going to update the prompt here, say make sure your approach is test driven. That is, write the tests before, let's just break it down for it. Write the tests before the implementation, and to start with a mock implementation where everything is to do. Okay, this should change the approach slightly. Why does it want to use this error? Okay. Anyway, let's have a look at what it produces here. So project setup, that looks reasonable. I don't really know why it wants to use this error, but we'll figure that out in a second, hopefully. Right, it has something here. Okay, so maybe that's just to make some description. Okay, I see what it's doing. It basically makes them printable with a nice text. Okay, that makes sense to me. But probably this might well be outdated, so we probably need to add this using cargo instead. Let's see, define the calculator interface. Okay, looks great. And it has defined all the tests, and okay. Okay. Great, so I think 12 steps. I feel very confident we can do this. And while we're not strictly doing vibe coding here, what we will try to do is make it as vibe as possible, which means that if we can avoid actually looking at the code, we will try to avoid it. We will try to focus on the test-driven approach and really try to get it to do its best in that. And so the whole idea is if we fix the interface and we have reviewed the tests, then the implementation can be changed as many times as we want to. With that, we're going to start a new context. Just going to remove that. And we have a project description. We have a set of tasks. So let's just write that out here. and say project description and tasks. Okay. Cool. We will not be using agents in this video, and so the whole point here is we want to do solid software engineering. In my experience, the moment you start throwing agents into the mix, what happens is it produces so much code that you get completely overwhelmed and you actually don't get to produce anything. So we've done this. Let's just have a look at the task list. We go here, we just copy this one across, making the new calculator, Rust calculator. Okay, and let's see. Then we need to add this error. Okay, cool. So I think we're ready to go. And as I said, we'll just ask it to implement things for us. We could copy things across, but basically we want to do as little as possible. That's the whole aim here, while still producing something where we are quite sure that the outcome is of high quality. Step 4, write tests. Oh, Ed wants to do that in the same file as well. Yeah, why not? Could you implement the tests from step 4? Yes, cool. And again, we have the basic tests here. I wonder, this does not seem to do everything from the project requirements. I guess that's coming in step 5. Okay, let's just see, when do we end doing tests? Okay. Yeah, there's no reason why we would go through this step by step. It can just do everything at once. As long as you get it to produce less than 500 lines, you're typically okay, unless your lines are extremely long. Let's see, we got the errors, we got some syntax here. That all looks great, and we have the order of operations. Okay, cool. At this point, I'm inclined to just check that things are working. Hey, and it does. All our tests are failing. Excellent. This is exactly what we want. Because now we are ready to implement. Oh wait, what does it do here? Implement, okay. Tokenize, evaluate, okay. So we're going back here. We will do. Could you implement step 7? See how that's going. Okay, so we have tokens, operator, add, subtract. Let's see. Tokenize. I guess at this point I would have loved it to write some tests for the tokenizer. There's a ton of code here, and it seems to me that we will have a lot easier debugging this if we knew what is going wrong with the tokenizer. On the other hand, like basically to tokenize. Yeah, okay, let's just accept this and then do pub crate and pub crate and pub crate. just add here. Could you write some basic tests for okay, so the whole idea here is that in just a bit things are going to go wrong for us. We will ask it to evaluate expressions and something will be going wrong and we'll have no clue whether it's the tokenizer, the expression evaluator, or where the error even is. And so just to make things slightly easier for ourselves, we're going to add a set of extra tests just to test that it's actually doing the right things. And as you see, these tests are super simple, right? We're just testing, well, if you put this in, you would expect to get this output and so on and so forth, right? So that it's not that they are super complicated. Okay, let's test now and see. Wait, holy crap, we're done here. I did not expect that. Okay, so clearly we've chosen a task that was too simple and we are only missing this one function. I mean, that's not bad. Like, probably we've had like 10 minutes of coding here and we started out with all the tests just failing and all of it just working, which is like completely unexpected. Okay. Well, I guess what was after step 7? Like, because there's still like another complete the implementation. But we did this already. Oh, I see, it went ahead and it actually implemented step 8. Oh, it didn't implement step 8. But it went ahead and just did the full evaluation. Or just went ahead and did the full implementation. It was not supposed to do this. Okay, this is one of the things that you have with LLMs. Sometimes they're just being overly ambitious and just going ahead and doing stuff that you actually did not ask them to do. Which, yeah, is nice at times. Like, it was a nice surprise now, but I guess I would have preferred that it did it more step by step. Okay, well, let's go back. Could you implement this function as well? Okay. And I think the last step, step 10. Right, we need to do manual testing. That's step 10, step 11. Okay, we need to implement. Okay, this plan is completely screwed now. Anyway, let's update this. Could you implement the main function? Okay, so as you've seen, we have actually not spent much time looking at the code. Like, we barely looked at it, and all the tests are passing, which means that we can have some confidence that it's actually doing what it's supposed to do. We are not, of course, we're not 100% sure that everything is correct, but this is why we'll be doing manual testing. But I think there is a reasonably good chance that it will be doing quite a lot of it, right? Because we've covered all the basics here. We have covered that it does advanced expressions. We have covered that it gets syntax errors when it should be getting division by 0. So, but let's try it out now and see what happens. Hey. Oh, yeah, that's right. That's syntax error. 2 plus 8 times 7. Will you look at that? So 7 times 7 is 49 plus 7 is 56 plus 2 is 58. It's correct. That's pretty cool. And it even allows us to quit. Okay, I guess that's pretty much it. I mean, let's just try to see if we can break this. Oh, that's a good one. Yeah, there are some good tests here. Let's just see what happens when we run the test. Okay, cool. So this actually goes to show that our initial set of requirements wasn't even solid enough. Let's just see if we can get it to fix this. So again, the key thing here is, rather than just trying to feed a runtime error into it, which is how you'd normally do vibe coding, we actually put test outputs for which it knows exactly what is all of the possible things that could happen here. Like, it has the tests, it has the context of the implementation, and it can use this to reason about where is the error, how can we solve this. And let's see. Right, this. I'm curious whether this will ruin things or make things better. Because technically this should also be like this, right? And there's nothing wrong with that. Okay, last was okay. Let's see. Maybe let's just check what happens. Right. Let's see. So it might be defining. Let's just try to run this and see. It's just the small numbers now. So we have 3 minus minus 3. That gives 6. What happens if we do 3 minus minus 3? Okay. What if we do 3 minus 3? It's okay. Then I would also expect 3 minus minus 3 to work. Wow. That's actually pretty impressive. Like, it's literally only if you put a space, it will give you a syntax error. Okay, that's pretty good covering. Plus 3. Okay, so this one, it does claim a... So we're not allowed to do plus 3. Okay, cool. So basically, it only takes into account unary minus, and it does not accept unary plus. That's pretty cool. Like, it makes a lot of sense because it's always implied anyway. I really like this. That's cool. Okay, let's just quit again. Okay, we have one error left, or one test left to finish, which is the very small numbers. Let's just try to run the tests again and see what's actually going wrong here. Left is giving this, and right is giving that. Okay. It's just one test failing. I wonder what type we are using for this. Let's just see. So we're using F64. So technically this should all be okay. Okay, let's Look, let's not think too much about it and just have it run it. Oh, I see. This is right. That is really not a fix. Okay, this is a great example of something where LLMs, they really ought to just be not used for development. Like, come on. This is ridiculous. Okay. Arguably, this result is correct. It is the test that is wrong in this case. I would say it at least seems to me that we need to test within a tolerance. And so I would do, let's see, small. This epsilon, I wonder. I mean, this doesn't make sense either, right? Because it needs to be relative to the number, right? Because you're having the exponent. So in the floating point, you have the exponent, which is separate from the mantissa. And basically what we want to test is that the mantissa is correct or correct within tolerance. And we want to test whether the exponent is correct. So let's just change this test as follows. One, test that mantissa is correct within tolerance. To test that the exponent is correct. Okay, let's see. This one is not needed anymore. Let's run this again. Still passes. Okay. Let's change the scope of this test. Could you change the test to use an array of input output to a test and then test them one by one. That makes sense. Okay, cool. Test. And then let's change this to corner cases. Could you add some really large numbers as well and add some more complex expressions. Okay, now we filled this one teaser 1. Oh, expected normalized. Oh, but this test is wrong. Expected normalized. That's not true. We don't expect that if the exponent we're using is different, right? So expected needs to be multiplied by this, and then we can get rid of these two because we don't need that anymore. Okay, but now we get another weird one. Let's try to do this one. Oh. Fuji point. This one, wasn't it? Let's see. Yeah, it was. Let's try to do that one. And okay, so there we go. Now all our extended tests are also working. And surprisingly, the real issue here was not really with the implementation, but actually the test itself, because testing the corner cases can be a bit tricky, and the LLM had made some assumptions that weren't really there. But anyway, I mean, in total we've maybe spent 45 minutes and we have quite a lot of test coverage here. How much test coverage we actually have, I don't know. Let's see. Okay, 71% test coverage. Okay, let's have a look here. So this seems like, okay, let's see what we're not covering. Well, technically, we seem to be covering quite a lot. Okay, so this one we're not covering. Okay, so these basically, it's all the syntax errors we are not covering well. Okay. It's actually exclusively the syntax errors. Oh yeah, and then of course it's the main program. We're not covering that one as well. Okay. Well, all in all, I think that's pretty good test coverage. Like, we can do more with the syntax errors testing, that it's actually giving the errors that we expect. But all in all, I'm pretty happy with this coverage. It's definitely not bad, and it's especially not bad for something that was quite quickly thrown together. But one of the cool things here is we've developed a calculator. We are pretty sure that it's behaving the way we should. And if we want to understand what it does on an interface level, all we have to do is read the tests. And unlike the main code, the tests are really, really easy to read, right? Because you read here, okay, if I evaluate this expression, I'll get a syntax error, and so on and so forth. You can also do here, like looking at the tokenizer, saying, okay, well, this is easy to read, it's easy to understand, and it takes out a lot of the complexity. And going about it this way is a really, really nice way to get good LLM outputs. If you're interested in hearing more about this particular topic, let me know down in the comments. I'm really happy to go deeper into it, and one of the things I actually want to do in the slightly longer run is make a longer video about how to do this with APIs. So basically the idea here is to do exactly the same. We start out writing a bunch of tests for the API and first then start implementing the API afterwards using LLMs. Thank you for watching. I hope you've enjoyed the video. If you have any questions or comments, let me know in the comments below. Also, feel free to join the community, community.trolls.im. See you in the next video.